In this video, I'll be covering a brand new development kit from Nordic Semiconductor. Nordic was kind enough to provide me with 3 of their new nRF5340 LE audio development kits. I got my hands on these pretty early before the release. They launched today, but I've been able to play with them and test them out and see the different functionalities and the different new features of LE audio that are coming in the market. If you haven't heard, LE audio is the next generation of Bluetooth audio. So just like Bluetooth Classic or Classic Audio has been around 20 years now, and it's had a good run, but it's now getting dated. And so LE audio came around to provide new features as well as enhancements on top of Bluetooth Low Energy instead of classic Bluetooth. Now, if you're new to Bluetooth Low Energy or you just need a refresher on the technology, then be sure to check out my Intro to Bluetooth Low Energy ebook that's available to download for free from my website. It's a 100-page guide that you can read within a weekend or in under 4 hours, so you can get started with developing your first Bluetooth Low Energy application. LE audio was introduced back in 2020 at CES in Las Vegas, and the majority of the Bluetooth LE audio specs have been released. There are a few others that are remaining, but most of the specifications have been released and can be downloaded from the Bluetooth SIG website, bluetooth.com. The Bluetooth that we know and that we've been used to is now referred to as classic audio, whereas the new Bluetooth audio standard is referred to as LE audio. LE audio does require the support of a feature that was introduced in Bluetooth 5.2 called isochronous channels. What's really exciting about Bluetooth LE audio is that it introduces new use cases as well as enhance and improve over the traditional use cases that we've been used to with classic audio. Some of these new use cases include broadcast and audio sharing. This could be location-based or personal-based. Location-based means it's available based on the location that you're in. Say, for example, public TVs or public announcements in airports and different venues. Personal-based broadcast or audio sharing is where you can share your audio and the music that you're listening to with your friends and family around you. LE audio also introduces support for hearing aids as a standard. This allows us to migrate from the dated and old telecoil systems that have been in use for decades. Another exciting feature of LE audio is multi-stream audio, where it provides support for multiple independent audio streams that are synchronized to one or more devices. The list goes on, and another benefit is lower power consumption. This is especially useful for devices that need to run on small batteries or devices that need to increase their battery life while staying at the same physical size as before. Some of the new exciting applications with LE audio includes public announcement system or PA systems in airports, movie theaters and cinemas, conference centers and venues where you can have multiple audio streams streamed in different languages to different people coming from all around the world and hearing the audio in their own native language. Other examples include museums and TV screens in gyms and public venues, as well as truly wireless systems where you can have 2 earbuds independently connected to a device and streaming audio that is synchronized across these 2 devices. And even though this exists currently in the market, the new LE audio standard will standardize this implementation and give you the ability to use products from different manufacturers thanks to interoperability. Now, we briefly mentioned LC3, and this is the new codec that was introduced alongside the LE audio standard. LC3 is a much more efficient codec that is mandatory for all LE audio devices. It achieves higher quality audio at the same data rate as compared to SBC, which was the mandatory codec for classic audio, or you can even achieve slightly higher quality at lower data rates than the original SBC codec. And you can have a listen for yourself on the Bluetooth SIG website. I'll include a link in the description below. You can have a comparison between SBC and LE audio streams right on your computer and through your headphones. Now, we touched on the broadcast aspect of LE audio, and this brings us to defining the 2 modes, the 2 main modes that LE audio operates in. And those are connected isochronous streams as well as broadcast isochronous streams. Connected isochronous streams requires a connection between 2 devices, so inherently there is a limit of number of connected devices or number of streams that can be streamed to independent devices. However, it does provide high reliability because of the feedback loop from the receiver devices back to the transmitter, telling it if it lost packets or it needs retransmission of some of the packets. It also provides a more efficient utilization of the bandwidth and the spectrum, and that's because retransmissions only occur based on feedback from the receiver. In addition to that, it provides support for bidirectional audio streams. So think of an earbud that has a microphone built in, then you have a stream, for example, going from your smartphone to your earbud, but you could also have the same stream going back to the phone and encompassing the microphone audio being captured on the earbud end. So that's in terms of connected isochronous streams. In terms of broadcast isochronous streams, you can have an unlimited number of devices listening to the same stream broadcast by that broadcaster. Now, this is a very powerful feature and introduces a whole new use case that we never had before with our existing Bluetooth audio standard. And the cost of this is that we have inefficient use of the spectrum compared to when using connected isochronous streams, and that's because retransmissions may occur regardless of whether there is feedback, because obviously there is no feedback from the receiver back to the transmitter in this case, in the case of broadcast. So the broadcaster may decide to retransmit a packet 2 or 3 times, even though it is not receiving feedback, that it is actually being received correctly and without any packet losses. One interesting thing about broadcast audio is that broadcast streams can be secured with a passcode, or they can be open to the public where anyone can tune into them. So you can expect that LE audio, since it's in the very early stages, that devices will still support classic audio. We'll expect to see that for a long time, and we'll have devices that maybe support both standards for a while until the transition goes to LE audio in the future. Okay, so enough of the theory. Now let's get into the really cool stuff with the actual development kits from Nordic Semiconductor, the nRF5340 LE Audio Development Kit. So as I mentioned, today Nordic Semiconductor released their LE Audio Development Kit based on the nRF5340 Development Kit and chipset. This is what the audio development kit looks like. This is the packaging, and this is the actual development kit. These kits will be sold in single units, but really to be able to practically develop and test LE audio applications, you'll need at least 2 of these development kits, and 3 is probably the minimum. Especially if you want to develop broadcast isochronous stream applications, you'll need at least 3. So the 2 different configurations that this development kit supports, one is called the gateway, the other one's called the headset. Think about the gateway being the streamer or the audio source, and the headset being the audio sync in this case. Let's look at the buttons on the development kit itself. So we have power switch, we have a battery connector up top here, and it comes with a battery. This is what the battery looks like. So lithium polymer battery, 1500 milliamp hour. These are the different buttons. We have button 5, which is used to mute. Button 4 is used to send a test tone to the headsets. This is only available from the gateway side. So this is kind of a quick way to test synchronization between multiple headsets. You have a play pause button to stop the playback and resume. You have volume up and volume down, or volume plus and volume minus. You have a reset button to reset the board. And in order to have setup, I'm going to be setting up 3 of these development kits, one acting as the gateway and the 2 others acting as the headsets. One of them is going to be acting as a left headset, and the other one is going to be acting as the right headset. Now we'll be testing both the broadcast and connected use cases, and just in case you were not aware, the nRF5340 development kit and the audio development kit as well is based on the NRF Connect SDK, which is based on the Zephyr RTOS project. This is different from the nRF5 SDK, the original SDK from Nordic, that is not supported on any of the 5340 development kits, whether it's the audio or the regular one. A couple of things to keep in mind as of the recording of this video: the streams are unidirectional, so they are gateway to headset only. That means we cannot implement the microphone going back to the smartphone example use case. So, and this isn't only in CIS, in connected isochronous streams. In broadcast isochronous streams, obviously we only have unidirectional streams anyways. And in the current version of the application, there's no bootloader used, and so device firmware update is not supported as of now. To use the LC3 codec, in this case, requires access to the LC3 codec repository, which is private and requires you to sign a licensing agreement with Nordic Semiconductor. If you are interested in this, then contact the sales department or your sales representative within your region. So I won't go through all the steps required to set up the repositories as well as build the applications for the nRF5340 LE audio development kit, but those are detailed in the link included in the description below the video, so you can refer to that and then come back and follow along after that. So once you have everything set up, you will find a folder called nRF5340 audio, and this is located in the nRF applications folder under the NCS folder that you create to clone the repository, including nRF Connect SDK as well as Zephyr. Inside this folder, you'll see a few files. For the purpose of just testing, there are a few files that we need to keep in mind. The first one is the prj.conf, and that is included here. And this includes the configurations needed for building the application. There are two specific options that are important. By default, the application will run, the gateway application specifically, will run over USB connected to an audio source such as a computer and use it as its audio output. For that, you don't need to add any definitions in this file, but if you want to use the line in, then you would need to define this line here, config audio source I square S equals Y. I'll be using the USB audio. The other thing to keep in mind is that by default, the application or the repository will build for the connected isochronous streams, CIS. If you want to add the broadcast isochronous streams, then you add a line here. I have it disabled for now, but you add a line that says config underscore transport underscore bis equals Y. And then you just build the application again and flash it to the development kits. So for building this is different than the other nRF Connect SDK applications. There is a build script that's included, and that is located under Tools and Build Prog. So under here, you have a Python script that you can use to build and program the DK with the application. A few things to keep in mind here. There is a file called nRF5340 audio DK devices.json, and this is where you define the different devices that you want to build for and program. So as you can see here, I have 3 devices. These are 3 development kits. Each of them has a SNR or a serial number, as well as a role that it plays. So in this case, there's one that plays the gateway role and 2 others that play the headset role. And in the case of the headset, you can define the channel to be left or right. If you want to find the serial number for your device, then once you have a DK connected, you can run nrfj prog-i. Once you figure out the serial numbers, then you can go ahead and edit the JSON file and include those serial numbers and assign the roles to the DKs based on your preferences. Once you do that, we can use the build script to build the application. Now, before you build the script, make sure that you recover the device. So it does come with a demo mode, but if you want to build the application from scratch within the repos that you cloned, then you would have to recover the device first. And we do that by running the following command. So I am running both commands in the same line, and that's to recover the coprocessor, which is the network processor, as well as the main processor. You can run those separately. Here, the nrfj prog --recover coprocessor cp_network. You can run that separately and then run the main processor recovery operation separately, but I'm including it in the same command. This is usually needed if you want to flash the application again. Once you do that, depending on the development kit that is connected and its serial number, the build prog Python script will detect which DK is connected, and it will flash it with the appropriate firmware based on the role and the configuration for it. So for here, I have the 603 connected, which if we go back to the JSON file, this is the gateway. So if I run this script, I've already programmed or I've already built this application, so you won't see any of the build steps. However, it will detect here that the serial number or the gateway device is connected. And then after you run the program, the script, and it detects everything and programs it, you'll see that the core app was programmed as well as the network coprocessor as well. So you want to connect each of the DKs and go through the same process. This is all detailed in the link in the description below, but I'm just including it here for your reference and just to know what you are going to run into. So here I'm running the connected isochronous streams demo, and I have over here the first development kit. This is acting as the gateway. It will light up in green. I have the right development kit connected to a speaker and the left development kit connected to a speaker, and I have the gateway connected to my computer and using it as the audio source. So I'll start running the music. If I unplug the DK, you'll hear that the music is playing directly from the computer. I'm going to connect the development kit now. We won't be hearing anything yet because I don't have any streams going to async or audio syncs, because the two development kits for the right and left are turned off. Once I turn each one on, so I'm going to turn on the right development kit, and this one is acting as a headset, so is the other one. This one will turn purple, indicating that it's the right channel or the right headset, and it will beep up. And then as you can see, there's going to be a blue LED flashing on this one, and then as well as on the gateway device. Once I do that, the next step is to press the play pause button on the headset, and that will stream. We can control the volume directly from the gateway. Let's go ahead and turn on the left side. And again, we need to press the play pause button once the blue LED becomes solid. And there you go, now it's playing from both speakers. We can turn the volume down. In this case, they are synchronized, so the volume is actually controlling it for both. If it was in the broadcast isochronous streams, which we'll see next, the volume can be controlled separately for each. We can control the volume as well from the gateway directly, and we can play a test tone to make sure that it's synchronized. As you can hear, the sound is actually coming from both sides. Okay, so I've just reflashed all the boards with a new build that builds for the broadcast isochronous streams, and you'll notice a couple of differences. The volume can be adjusted for each headset separately from the other one, whereas in the connected, the volume buttons on any of the DKs would be controlling the volume for all of them, for both headsets. Also, again, just to mention, I am running both the headsets off the batteries that are included, whereas with the gateway I don't need to use the battery because it is connected over USB to a PC that's acting as the audio source. So another difference is that the gateway in this case does not need to detect any headsets before it starts flashing the blue LED, and that's because it is broadcasting. It has no awareness of the other devices in the vicinity. So in this case, it'll be sending out one stream that is detected, or two streams, one for the left, one for the right, but they are sent out in broadcast mode, so they can be received by unlimited number of DKs. In my case, I have 2 DKs, but you could have up to, an infinite number of devices that are receiving the same broadcasts from this gateway device. So again, I'm going to be running the music. Now it's running, it's playing. We don't hear anything yet because we have not turned on the development kits. I'm going to start with the right development kit. When we see that the blue is solid on it, then we can press the play pause button and it'll start playing. I can decrease the volume. Then let's connect the other development kit. Once the blue is solid, I can press the play pause button, and now we have both headsets synchronized to this broadcast stream. I can adjust the volume just on the left side, adjust the volume up on the right side only. So in this case, they are operating independently. We can send a test tone to test the synchronization between the two. And we can disconnect this one, for example, and see that it does not affect the other device. Now in this case, we can't control the volume from the gateway because this is a broadcast stream and it's only being controlled by the broadcast receiver itself. So I hope you've enjoyed watching this video and you've learned something about the new LE audio standard and the new development kits from Nordic Semiconductor. Be sure to check out the links in the description below for more information and to download my free Bluetooth Low Energy ebook, The Intro to Bluetooth Low Energy, that's available to download from my website. Thank you for watching.